Okay, gang, today we're going to be using Pythagorean's theorem to find the distance between 2 points on a coordinate plane or in a word problem. The procedure to do this is to first plot the given coordinates, second, connect the coordinates with a straight edge, third, draw a right triangle such that the line drawn in step 2 serves as its hypotenuse. Remember, the hypotenuse is the C value in the right triangle. And then use Pythagorean's theorem to find the distance between those two coordinates. All right, so I'm going to do some examples with you, 4 of them to be exact, and you're going to try the other 4 on your own. So for number 1, we start by plotting those 2 points, negative 2, 9. We go left 2 and up 9, and that 9 is all the way at the top. And then 6, negative 3, we go right 6 and down 3 all the way to the bottom. Then take a straight edge or a ruler and neatly connect those 2 points. Now, to make this be a right triangle, we're going to start at the top point and drop a line down until we are at the same spot as the bottom point, and then draw a horizontal line over. And then this corner here serves as our right angle to our triangle. So now we have to find some measurements to use in our formula. So we can find the base and height of this triangle. This would be 1, 2, 3, 4, 5, 6, 7, 8 units long, where the height is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units long. So those are going to be our A and B. We can plug them into Pythagorean's theorem, which is A squared plus B squared equals C squared. And we get 8 squared plus 12 squared equals C squared. So 8 squared, hopefully you remember, is 64. 12 squared is 144 equals C squared. 4 plus 4 is 8. 6 plus 4 is 10. Carrying the 1, we get 208 equals C squared. And then last, we take the square root. Now, 208 is not a perfect square, so we could just use our calculator and round it to the nearest tenth. If you do that, we do square root of 208, and we get about 14.4. But we could also simplify this in simplest radical form. I'm going to change this to approximate since we did round. So to put it in simplest radical form, we're going to make our factor tree of 208. 208 is 2 times 104, 2 being prime. 104 is 2 times 52, 2 being prime again. 52 is 4 times 26. Oh no, I just did that wrong. 2 times 26, 2 being prime again. And 26 is 2 times 13. So now both of those are prime. We can put them under our radical. So we have square root of 2 times 2 times 2 times 2 times 13. And these 4 2's make a perfect square. So we have 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's 16 times 13, which is, if you take the square root of 16, 4 radical 13. And we can prove that that is equivalent by going back to our calculator, taking the square root of 13, and multiplying it by 4, we get 14.4, which is what we wound up with to begin with. So we've proved that we've done it all correctly. So 2 possible answers are 14.4 is equivalent to approximately C, and 4 radical 13 is exactly C in simplest form. All right, let's take a look at number 2. For number 2, again, we start by plotting those 2 points. So we have find the distance between negative 4, negative 3, and 4, 6. So I'm going to plot those 2 points. So negative 4, negative 3 is going to be down here. And then 4, 6, we're going to go right 4 and up 6. Give me this point right here. We draw our line between those to serve as the hypotenuse. Then drop a line down from the top point and a line over from the side point, making this be our right angle. And now we can use those to figure out our distances for the base and the height. So on the base, we have 1, 2, 3, 4, 5, 6, 7, 8 units. And for the height, 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So 8 and 9 are going to go into our formula. So 8 squared plus 9 squared equals C squared. So 64 plus 81 equals C squared. If you add those up, 1 and 4 make 5, and 8 and 6 make 14. So 145 equals c squared. Take the square root, use your calculator. Square root of 145 is approximately 12.0. So c is about 12.0. So now we can also simplify that and see if it can be simplified into simplest radical form. We know since this number ends in 5, it can be divided by 5. And 145 divided by 5 is 29. So 5 and 29 are both prime. So this cannot be simplified. The simplest form in most exact form would just be the square root of 145. All right, so I gave you two examples using the coordinate plane. Now let's take a look at some of the word problems. I think I had mentioned that I was going to do 4 with you. I'm only going to do 3 with you. I had the number messed up. So for number 5, we have Missy rides her bike 8 miles south and then 14 miles east to visit her friend Leah. What is the shortest distance between Missy's house and Leah's house? So I'm going to draw a little picture that shows her route. So Missy rides 8 miles south. So if this is where she's starting, 8 miles south would be going this way. And then 14 miles east would be this way. So this is where she ends up. The shortest distance between 2 points is always the most direct route. So this would be the shortest distance right here. So if this is 8, this is our right angle, and this is 14, we want to find C. So we have 8 squared plus 14 squared equals C squared. So 16, or not 16, whoops, 8 squared is 64. 14 squared is 196 equals C squared. Add those up, 6 and 4 make 10, carry the 1. 6 and 10, because it's 6 plus 9 plus 1, so 6 and 10 make 16, carry the 1. And then 260 is c squared. Take our square root, and 260 is not a perfect square, so we could simplify this. C would be about square root of 260, 16.1 miles. But we could also put this in simplest radical form, or at least try. So we have 260, breaking that down, that would be 2 and 130. 130 would be 2 and 65. 65 is 5 and 13. So we have square root 2 times 5 times 13. 2 and 2 make a perfect square of 4. 5 and 13 make the 65. Square root of 4 is 2, and we leave the 65. So the most exact amount of miles would be the 2 radical 65. You're going to do 6 on your own. Don't make this too challenging. Just add the distances that are the same together. All right, good luck. I'll be around to help you out.